Hello guys, my name is Pino and I will be walking you through question 2 from the April 6, 2021 mathematics and for question paper. Question 2.1 states that if 8 sin theta plus 5 is equals to 0, determine the value of cos squared theta plus tan theta multiplied by cos theta without using a calculator. So we have to first make sin theta the subject of the formula. So we have 8 sin theta plus 5 is equals to 0. We take this 5 to the right, it's going to change sign from positive to negative 5. And from here, we divide both sides by 8. That 8 will cancel out with that 8. And sin theta will be equals to negative 5 over 8. We have our soccer tower. And sin theta is equals to opposite over hypotenuse, which we can also write as y over r. The sin theta is negative, so according to our all these sides are positive. This side only sign is positive, and the third quadrant only tan is positive, and the fourth quadrant only cos is positive. So this sin theta is negative, so it's either this side or that side. So we can just guess that it's that side. So we have our theta, and it's equals to sin theta is equals to opposite, which is negative 5, over hypotenuse, which is 8. So the hypotenuse can never be negative, it's always positive, so that negative sign belongs to the opposite. So we have to figure out what the adjacent side is, which we can also call our x. So we use theorem of Pythagoras. So with theorem of Pythagoras, we have r squared is equals to x squared plus y squared. We make x squared the subject of the formula by taking this y squared to the left. So we already have the r squared, which is positive. So when this comes to the left, it's going to be negative y squared, and x will be equals to the square root of r squared minus y squared. So we already have r and y, so our r is 8, we square it, minus the negative 5, which is equals to our y. So x will be equals to 8, the square root of 8 squared minus negative 5 squared, which is equals to the square root of 39. So this side is equals to the square root of 39. So we have cos squared. No, we don't have the cos squared. So we have to determine what cos squared theta plus tan theta multiplied by cos theta is equals to. So we have cos theta is equals to adjacent over hypotenuse, which we can write as x over r. Our x is equals to the square root of 39, and our r is equals to 8. So we have cos squared theta and the cos theta there, so we have to determine what the tan theta is equals to. So cos theta we determine as the square root of 39 over 8. So tan theta is equals to opposite over adjacent. Our opposite side from that angle is negative 5, and the adjacent is equals to the square root of 39. So tan theta is equals to -5 divided by the square root of 39. So cos squared theta plus tan theta multiplied by cos theta is equals to cos squared theta. So our cos is the square root of 39 over 8 squared plus tan theta. Tan theta is equals to -5 over the square root of 39 multiplied by the cos theta. The cos theta is equals to the square root of 39 over 8. So we can use our calculator from this point. The square root of 39 divided by 8 squared plus -5 divided by the square root of 39 multiplied by the square root of 39 over 8. This is equals to -1 over 64. The instruction without the use of a calculator, it doesn't apply when you are already at this point. So the answer for question 2.1 is equals to -1 over the square root of 64. But you can also, so we had our cos squared theta plus tan theta multiplied by cos theta. Tan theta, we know that it's sin theta over cos theta multiplied by cos theta. So that cos theta will cancel out with that cos theta. So instead of question 2.2, we have to prove that cot of 90 plus theta is equals to -tan theta. We know from our trigonometric identities that tan x is equals to sin x over cos x, and that cot of x is equals to 1 over tan x. So if cot of x is equals to 1 over tan x, cot x will be equals to cos x over sin x. So our cot of 90 plus theta will be equals to cos of 90 degrees plus theta over sin of 90 degrees plus theta. And we will use our formula sheet to determine the cos 90 plus theta and the sin 90 plus theta. On our formula sheet, we are given in the form of a and b. So a will be equals to 90 degrees and b will be equals to theta. So we have the formula for cos and the formula for sine. So with the formula for cos, if you had a positive there, you'll have a negative. If you had a negative between a and b, you'll have positive between these two trigonometric variables. But with the sin a, if you had a positive, you'll have a positive. If you had a negative, you'll have a negative. So this will be equals to, so the formula for cos, we are focused on that one, cos a multiplied by cos b. So we will have cos 90 degrees multiplied by cos theta. We have a positive, so here we'll have a negative. Sin b multiplied by cos a, in our case, sin a multiplied by sin b, so in our case it's going to be sin 90 degrees multiplied by sin theta over sin 90 degrees plus theta. So we use that formula for sine. This will be equals to sin of 90 degrees multiplied by cos of theta plus, so with our sign, if you had a plus, you also have a plus, sin theta multiplied by cos of 90 degrees. Cos 90 is equals to 0 multiplied by cos theta minus sin 90 degrees is equals to 1 multiplied by sin theta over sin 90, which is equals to 1 multiplied by the cos theta plus sin theta multiplied by cos 90, which is equals to 0. So you can also use your calculator to verify the sin 90 and the cos 90. 0 multiplied by any number or variable is equals to 0. So negative 1 multiplied by sin theta is equals to negative sin theta. 1 multiplied by cos theta is equals to cos theta. Sin theta multiplied by 0 is equals to 0. So you have negative sin theta over cos theta, and like we said, sin x over cos x is equals to tan x. So sin theta over cos theta will also be equals to tan theta, and this will be our answer for question 2. Question 2.3, we have to simplify as far as possible sin x plus tan x over cosec x plus cot x. So we can write this as sin x plus tan x divided by cosec x plus cot x. We know that tan x is equals to sin x over cos x, not theta x, and cosec x is equals to 1 over sin x plus, and cot x is equals to cos x over sin x. So this is divided by 1. So we can use this little thing over here. So we multiply this by that. So in our case, we multiply that by that. So 1 multiplied by cos x is equals to cos x. And we also multiply that by that. So we multiply the 1 by, so we put this sign here. We multiply that by that. 1 multiplied by sin x is equals to sin x. And we also multiply this by that. So cos x multiplied by sin x is equals to sin x cos x divided by, we still use that, this multiplied by that. So sin x multiplied by sin x, which is equals to sin squared x. This multiplied by that, so the sin x multiplied by the cos x is equals to sin x cos x. This multiplied by that, so sin x multiplied by 1 is equals to sin x. So from here, we have to change this division sign into multiplication, and when we change it, we have to flip the sin x plus sin x cos x divided by the sin squared x. So the sin squared x will be our numerator, and this part sin x plus sin x multiplied by cos x will be our denominator. So from here, we have sin x, and we also have sin x there. We have sin x cos x, and we also have sin x cos x there. So that part can cancel out with that part because there is a multiplication in the middle. So we'll have 1 over cos x multiplied by sin squared x divided by 1. Sin squared x divided by cos x and we know, so we can break down the sin squared x as sin x multiplied by sin x over cos x. And we know that sin x over cos x is equals to tan x. So this will be equals to tan x multiplied by that sin x, and we have simplified this as far as possible. Question 2.4, we have to prove that sec theta plus tan theta divided by cos theta is equals to 1 divided by 1 minus sin theta. So let's take the left hand side and this will be equals to sec theta plus tan theta divided by cos theta. So from here, we know that sec theta is equals to 1 over cos theta, and that tan theta is equals to sin theta over cos theta. This we divide by cos theta. So in this case, the denominators are the same, and if the denominators are the same, we add the numerators. Or you can also use that little thing and from here this is divided by 1. We are changing the division sign into multiplication sign, so this has to flip. The denominator has to be the numerator and the numerator has to be the denominator when you introduce a multiplication sign where there is a division sign. So we have 1 multiplied by 1 is equals to 1. 1 multiplied by sin theta is equals to sin theta. On our denominator, cos theta multiplied by cos theta is equals to cos squared theta. So our trigonometric identities, sin squared theta plus cos squared theta is equals to 1. This is also available on our formula sheet. We make cos squared theta the subject of the formula by taking this sin squared theta to the right. So cos squared theta will be equals to 1 minus sin squared theta. So in the place of the cos squared theta, we will substitute 1 minus sin squared theta. In the place of the cos squared theta, we substitute 1 minus sin squared theta. And to make things visible and simple, let's write this one as 1 squared minus sin squared theta. So this is a difference of 2 squared. So if you had a squared minus b squared, this will be the same as a minus b, a plus b. So this will be equals to 1 minus sin theta, 1 plus sin theta, because we have a difference of 2 squared, 1 squared minus sin squared theta. So the 1 plus sin theta will cancel out with that 1 plus sin theta, and this will be equals to 1 over 1 minus sin theta, which is equals to our right hand side. Question 2.5, we have to solve for alpha when sec of alpha over 2 plus 5 degrees is equals to negative cosec 20 degrees minus alpha. We know that 1 over cos x is equals to sec x, and that 1 over sin x is equals to cosec x. So we can express that equation as 1 over cos of alpha over 2 plus 5 degrees is equals to negative 1 over sin of 20 degrees minus alpha. And we can cross multiply, or we can just flip. We make denominator then our numerator, but if we let the numerator be the denominator and the denominator be the numerator on the left hand side, we also have to do the same on the right hand side. Alternatively, we can cross multiply, we will still get the same answer. So we have that negative sine of 20 degrees minus alpha. So if we had negative, for example, if we had negative sine 30, this is equal to negative 1 over 2. So if we put this negative inside the parentheses, we still get negative 1 over 2. So negative sine theta, so we can define that negative sine theta is equal to sine of negative theta. But negative cos theta is not equals to cos of negative theta. So this only works with the sine. So we can put this as cos of alpha over 2 plus 5 degrees is equals to sine of negative, so we move that negative inside the parenthesis, 20 degrees minus alpha. So this negative multiplied by the 20 is equals to negative 20 degrees. This negative multiplied alpha, this negative multiplied by that negative alpha, I mean, will be equal to positive alpha. And we are told that alpha must be between 0 and 90 degrees. So from here, if we had sine of 30 degrees, this is just the same as cos of 90 degrees minus 30 degrees because of our complementary angles. So sine 30 is equals to 1 over 2 cos of 90 minus 30 degrees will also be equals to 1 over 2. So we can change this sign. We can change this sign and write it as cos, but in order for us to change this sign and write it as cos, we have to minus whatever it is that is inside this with 90. So we have 90 minus negative 20 degrees plus alpha. This will be equals to cos of 90 degrees. This negative multiplied by that negative will be positive 20 degrees. And this negative multiplied by that positive alpha will be equals to negative alpha. So 90 plus 20 is equals to 90 degrees plus 20 is equals to 110 degrees minus alpha. So if cos of alpha over 2 plus 5 degrees is equals to cos of 110 degrees minus alpha, it means that whatever it is that is inside this is equal. So we have cos there, and we also have cos that side. So, and we are saying that this cos is equal to that cos. So in order for this cos to be equal to that cos, it means that whatever it is that is inside both of them will also be equal. We are not dividing by cos. We are just saying that this alpha over 2 plus 5 degrees must be equals to the 110 degrees minus alpha. So we can group the like terms. We take that alpha to the left, it's going to change sign from negative alpha to positive alpha. And also this 5 degrees, we take it to the right from positive 5 degrees to negative 5 degrees. This will be equals to 3 over pi over 2, alpha over 2, I mean, plus alpha will be equals to 3 over 2 alpha. 110 degrees minus 5 degrees is equals to 105 degrees. We have to solve for alpha, so let's multiply both sides by 2 over 3. so that 2 will cancel out with that 2, and that 3 will cancel out with that 3. So our alpha will be equals to 105 degrees multiplied by 2 over 3. So our alpha is equal to 70 degrees, and it's between 0 and 90 degrees, like